All right, folks, we've got one more waves lecture to work our way through, this time talking about the electromagnetic spectrum. Now, it's been a while since our first waves lecture, so just a couple of reviews. First of all, electromagnetic waves are waves that don't need matter to transfer energy. So they can travel through matter, they can travel through gases or liquids or solids, but they don't have to. They can also travel out in space where there is no matter. And all electromagnetic waves are transverse in shape. So they all have those crests and those troughs. You don't have longitudinal electromagnetic waves. They're all transverse. So let's work our way through the spectrum. So things that differ among the electromagnetic waves, they all travel the same speed as each other. But they differ by their wavelength and their frequency. And if you remember, we've talked about that those things are inversely related. So the shorter the wavelength, the higher the frequency. And then we're adding one additional thing today. The higher the frequency, the higher the energy. So here we're kind of looking at the two ends of the spectrum. So first of all, we've got radio waves, really big wavelengths. You can kind of see them there. So if I was counting every second, I would have a fairly low frequency. It's also fairly low energy, which you can kind of guess just from looking at the picture. That wave is just kind of doing this. That doesn't feel very energetic to me, and it probably doesn't to you either. On the other end of the spectrum, we have gamma rays, little teeny tiny wavelengths, and they're really high frequency. It's boom, 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 boom with the waves. So in addition to being high frequency, it probably makes sense to you that they're high energy as well. So what we're going to do for the rest of notes today is go through the different types of waves in order from highest energy to lowest energy. So we're going to go from gamma to radio and focus on the everyday uses of these things, because we don't really think about using these things, but actually there's practical uses for all of them. So starting with our gamma rays, they are waves that have the shortest wavelengths and the highest energy. So they're really, really powerful because they are so energetic. They can penetrate nearly any surface. They can go through lead, they can go through concrete. These are the waves that, or the radiation that we'll talk about when we get to nuclear power. These are the things that are coming out. So everyday use, these do not cause you to turn into the Hulk, despite what the comics say. But if you're exposed to them like people near nuclear disasters, it can cause cancer. What's weird, though, is if they target it in a particular way, it can also kill cancer cells. So a lot of times, if you know someone going through cancer treatment, they'll say that they're going through radiation. That's exactly what's happening. They're being exposed to gamma rays that are killing off those cancer cells. One that's a little more familiar to us are X-rays. Now, X-rays are high energy, not quite as high as gamma, because remember, we're going down in order from most energetic to least. So they can't penetrate lead. So that's why if you go to the dentist and you're getting X-rays, they put that really heavy vest on you. That vest is made out of lead, and it protects the rest of your body from exposure to X-rays. Because if all they're trying to do is look at your teeth, they don't really need to see the rest of you. And the reason why we use X-rays to look inside our body is X-rays are energetic enough to get through all our squishy bits, our skin and our muscles and our organs, but they're reflected by the density of our bones and our teeth. So it gives back an image of our bones and our teeth without all that other stuff in the way. A little less energetic are UV. So they're energetic enough to enter our skin cells, but they don't really go any deeper than that. So everyday uses, lots of different things related to skin. So this is how people get suntans. It's also how people get sunburns. And if it's gone to the extreme, this is also why a lot of people get skin cancer. UV can also be used to pick up things that are invisible to us otherwise. So when people leave fingerprints, like at a crime scene, they're not always visible to the naked eye, but you can shine a UV light on it and a lot of times pick up on those fingerprints you wouldn't have otherwise seen. So, quick review before we move on. So, gamma rays are the most energetic. They go right on through our body like we don't even exist. X-rays can go through soft tissues, but not more dense things like our teeth and bones. And then UV can penetrate our skin, but nothing internal. So through the rest of these are less and less energetic. Now, light rays we've talked a ton about, so I'm not really going to talk about them much here today, but I did want to show you just how small of a chunk of the electromagnetic spectrum is what we can see. So here is the electromagnetic spectrum, and just where that rainbow colored part is everything we can see. Every color imaginable is in that tiny little range. So there's all these other waves around us. We just can't see them because they're not being able to be detected by our eyes. All right, moving down the electromagnetic spectrum to infrared waves. Now these are heat waves, so we can use them for anything related to heat. So they're used a lot of times in military purposes, to find people in camouflage or to find targets. The police use it if they're going out to look for lost people that maybe are unresponsive, so they're looking for their heat signature instead. And then you can also use them for heating lamps, whether you're talking about keeping food warm in a restaurant or keeping babies warm in the premature kids who need to be around like a lot of heat. Both of those are applications. Moving on to microwaves. Now, obviously, when I say microwaves, most of us think of a very practical one, which is microwave ovens. That is what's happening there. That is why your food's being heated up that way. But another one that you may not know is that is actually what cell phone towers are. Some of them are radio waves, but a lot of them are actually microwaves. And then speaking of radio waves, the very last one that we need to cover. We are at the end of the spectrum, so these are least energy, lowest frequency, longest wavelengths. And their everyday uses, obviously listening to the radio, whether you're talking AM or FM. But it's also radio waves, so it's radar. So you can use them for radar guns, for speed detection, or as we mentioned in the last lesson, Doppler radar that uses it for weather forecasting, sending out those radio waves and seeing if they're squished by the Doppler effect or stretched out.